My name is Lukas Bjorkman, and my project was on white-tailed deer seasonal activity in relation to climate change. So, just a little bit of background information. I was interested in seeing how climate change can cause massive changes in behavior in many mammals, such as polar bears, who are obviously forced to fend for themselves in the Arctic, as well as other mass migrations of larger animals and smaller animals such as wolves because areas become more hospitable or more dangerous for them to live in because of rising temperatures. Um, and I was interested to see if this may be extended to mammals and locations other than those that are most obviously impacted, like the Arctic and the uh, northern edge of the northern hemisphere. So I looked into my research question is, do white-tailed deer in the Burlington area experience a shift in behavior as a result of rising temperatures? My hypothesis is that the winter activity of white-tailed deer in Vermont will increase as a result of rising global temperatures and the disrupted normal behavior that comes along with it. So for my methods, I used a set of data from my naturalist called Burlington Mammal Spotting VT. It contains data from 2016 all the way through right now in 2020, but I just used the full year, so just 2016 through 2019. I filtered the data to only include the white-tailed deer spotting observations, as well as observations with potential NA values were omitted because that would mess up the data just a little bit. This was also done in R. Um, I eventually compared the winter and summer observation proportions to determine what I consider to be activity in the two seasons, and I defined winter as on or after the summer or the winter solstice and before the summer solstice, and I defined summer as on or after the summer solstice and before the winter solstice. And eventually, I also determined the significance of the data using a linear regression, using the data that was calculated that calculated the proportions to determine the activity. So these are just a few examples of the figures that I have. So for example, the first figure is a bar graph that shows the number of observations by date for an entire year, this year being 2016. And the red line on the graph represents the cutoff from summer to winter. In the case of this year, the red line is in a different place depending on the graph that you look at. The second figure is a similar bar graph, but in this case, it's just a singular season. This case being the winter of 2017, but it's laid out very similarly to the first figure. And finally, the last figure is a uh, a a scatter plot that shows the proportions of the winter observations plotted against the year um, that it corresponds to, as well as a linear regression line that helps realize the correlation between the two. So from my results, I found that there was a p-value of 0.6237 between the variables, which is not significant with an alpha value of 0.05. This means that there's likely a 62.37 chance that this data could be due to random chance rather than any actual significance. I also had an R-squared value of 0.1416, which means that only about 14% of the variance in the data can actually correspond to any correlation between the data. And so this leads me to believe that this data correlation using this data set is likely due to random chance, and no concrete answer can come to any sort of research question or hypothesis. If I were to do it again, I would like to reanalyze maybe using a data set that has more observations in it, a larger number of observations, or observations from earlier years where it would be more obvious, or we would have more opportunity to see correlation between rising temperatures um, and winter activity. But overall, my hypothesis, I would reject my hypothesis because it the winter activity isn't significantly increasing due to what is rising temperatures yearly.